to start modeling the pipes by starting with the pipes that are for the drain. And for that, first I'm going to be explaining to you how you can model the drain pipes of a parking space. And after that, we will head over to modeling the restroom drain pipes. So for this project at hand, which is the parking project, first we modeled its ducts, and then we saved that file. And now we're going to be talking about modeling the drain pipes for that same parking project. So I'm going to go over to a part of this project so we can discuss it. We have some floor drains which are referred to as AD. And if we look over here, we see some descriptions telling us that AD stands for area drain. Typical refers to the fact that we have one sample image for all the other drains, and its dimensions are 30 times 30. Alright, now from this floor drain, a pipe with the size 100 starts and moves down and gets to a riser, which is indicated by R53 here. Then we see that the size of this riser pipe is 150 and is referred to as the initials WP, which stands for waste pipe, from above to below or bottom, which is actually the direction in which the pipe goes, and then this junction comes from this level and connects to it. Now, if we move down here, we will find another drain is connected to a pipe with the size 100. It connects to another pipe with the same size, then it reaches a triode and connects to the riser. Now we have this exact same thing mirrored going on the other side, as in we have two area drains and another one here, then they all come together and connect to this riser over here. Now we have another description referring to the slope of these pipes, which is 1%. We might have these slopes of the pipes like this right next to them, or we might be given a chart which describes these sizes and everything about the pipes. So in that case, we would be able to use that one. Now this CO initials that you see right here, it stands for clean out, which may also be referred to as sikhzan in the workshops. So in case there was a clog in these pipes, they would open up this clean out vent so they can use the spring that they put in the pipe to unclog it. So remember that everywhere where we have a 90-degree turn, we would have to also place one of these clean out vents. We also have some other clean out vents which would be installed on the risers, which naturally would require their own elevations depending on which type they are. Also, we might see some clean out vents which are referred to as WCO, which stands for wall clean out, and they are the vents that are placed on the walls. We will see some samples of them later in the plan. So now we want to link this plan in our model, then we're going to adjust the pipe settings, and then we're going to start to draw them. So now we're going to go to the plan in which we drew the ducts. Then we will find the plan which says plumbing. As you can see, we have one plumbing and two plumbing for it. And also we know that these views, which are called plumbing, inside them we can find the drain pipes, vents, as well as the water pipes. So first let me rename them here. Right click and rename. And I'm gonna make this PO6 Sanitary. And then this one, which is plumbing 2, I'm gonna make it PO5 Sanitary. As in, we will be giving them the names which are related to the project. So now I'm gonna open PO6. I just double clicked to open it. Also, I'm gonna be closing this duct view because I no longer need it. Now I want to link the plan here, but first let me double check the units of the plan. And for that, first we were supposed to measure one part as a sample. For example, the width of this wall. So I'm going to use this measuring command, then measure the width of this wall, which gives us 0.15. So we figure out that its unit may be meter. But first we have to double check to make sure, going to the dimension style, and then modify the size that we just got. Then we go to the primary units, and our scale factor is supposed to be 1 as it already is, so it's correct. And now we click OK and close. So we're going to go back to Revit, then to the Insert tab, then we click on Link CAD. and select our plan, going to the project folder, then parking, DWG mechanical, then we're going to select sanitary pipe. Alright, now I want to link this plan and have it visible only in PO6 sanitary view. Because, for example, I wouldn't need to see this plan in the ducts view. So I'm going to check this current view only box, then go to import units and select meter. And if I had adjusted the positioning, I would have kept it as origin to internal origin. But now that we haven't adjusted it, I'm going to select center to center, then click open to load the plan in the file. Then we get a warning here. Let's go see what it says. It says one or more hatch regions were found in the imported file with unconnected boundaries. Let's read it again. One or more hatch origins were found in the imported file, which their boundaries are not connected. And now, because of that, what's going to happen? It says that these hatch origins will be ignored, or in other words, removed. Don't forget that this is a warning, not an error, which may be an obstacle. But it's still good for our information because there may be some hatches which we might not be able to see. Alright, now let's go position this plan right where it needs to be. So we're going to press AL, which is the shortcut for align command. Then I'm going to move the mouse on one of the grids, which is WB, and then click on it. And now I'm going to zoom in a little so I can find the WB grid from the plan. Then I'm going to click on it to align them together. Also, from the vertical axis, I'm going to stand on one of the grids. This one is grid W12. Also, now I'm going to go over to the plan and find W12 and click on it so that the entire plans will align together. Now we press escape. I can also select the plan, then double check to make sure it's the right file, sanitary pipe. Also, I'm going to pin it so that I wouldn't accidentally move or delete it and cause more problems. Not only that, I will be moving down here and remove the permission for selecting the pinned or the linked files. So far we have linked and aligned the plans. Now we have to adjust the settings related to the pipes. So to draw pipes, we're going to go to the Systems tab and click on the Pipe command. Try to memorize its shortcut right here, which is PI, because for now we will be using this shortcut a lot. Alright, so click, and now we do the same thing we did for drawing ducts, as in we have to adjust some settings in the Properties window, and some other settings up here in the ribbon, also some other settings here in the options bar which needed to be adjusted. So in general, we have to go through the same process as we did for the ducts. So first I'm going to go to the Properties window to select the proper pipe type. Here we have two different types. One is called chilled water and the other is called standard. Now the drain pipes which I'm going to be drawing here, their types are PVC, which we can't see here in the list, so we have to create it. So I'm going to select one of these pipe types and then go to edit type. Then before I change anything, I'm going to duplicate it and give the duplicated type the proper name, which we said is going to be PVC. Now we're going to click OK. Then we go to the segments and fittings and click edit. Once we do that, a new window will open, which is something similar to what we had for the ducts. And now we have to specify our fitting types. Before we head to the fittings, we have an item right here which says pipe segment. And if we open up its drawer, we will see some different segments for the pipes. For example, we have copper and iron ductile and polyvinyl chloride, which is that same PVC, polyvinyl chloride. We refer to it as PVC for short. We also have stainless steel, carbon steel. These are actually the different pipe segments which we have available. So now what does the segment mean? Remember that pipe segments does not refer to material, as in it's not referring to the physical material which we can differentiate by looking. As in, we can't just look at, for example, stainless and PVC and tell which one they are. Here in Revit, we have this pipe segment item, which in fact indicates the sizes for our pipes. So if I click here on segments and sizes, a new window will pop up under the name Mechanical Settings. This one has two sections, Duct Settings and Pipe Settings. And now from the Pipe Settings section, it is opening these segments and sizes for us. I'm going to close this, cancel, OK, and OK. I want to talk to you about the Mechanical Settings window. We have three different main ways to open this Mechanical Settings window. The first and the most important way is that we can go to the Manage tab, then we go to the MEP Settings, and then we find and click on Mechanical Settings. And now we have opened this window. The second way is through the Systems tab. Then here in the Plumbing and Piping section where we selected this pipe command, we see an arrow in front of it, and if we linger the mouse pointer on it a little, it says Mechanical Settings. So if we click on this arrow, again the Mechanical Settings window will pop up. Now the third way is using the shortcut MS. So I'm going to press the keys M and S from the keyboard so that this window opens. So these were the three ways that we had. Now when we go to Edit Type and then Edit, we wouldn't have to stop our work and close all these windows or use the shortcut to have that Mechanical Settings window. We have this button right here, as in when you click on Segments and Sizes, this Mechanical Settings window will pop up over all the other windows that you have open so that you can easily adjust your settings. Now here on the right, we see that we have Segment, the same thing that we just saw over here in the Pipe segment. We have those same things over here too. So no matter which one you select, down here in this chart, you will see some numbers. They are under the columns Nominal, ID, and OD. Now we know that the end of each pipe has an inner diameter as well as an outer diameter, and the wall thickness of each of those pipes may be different. We refer to the outer diameter and inner diameter as OD and ID for short. Now, for example, we want to talk about the size of a pipe. We would say that that pipe segment is copper, schedule A, with outer diameter 6.350 millimeters, and ID 4.530 millimeters. Isn't this a little complicated? Wouldn't it be hard to have to say the inner and outer diameters of every single pipe? Therefore, there has been an agreement on using the nominal diameter instead of all these. You might have also seen it as DN somewhere before, which would be diameter nominal. So here in Revit we have nominal, as in this copper pipe with set ID and OD, we could refer to it as copper pipe 6 instead, or copper pipe 8, or copper pipe 10. So this nominal is actually a name which is agreed upon. This nominal doesn't necessarily have to be something between ID and OD. It doesn't have to depend on them. You see, for example, for 8, this one's even more than the OD. We also have the same thing for number 10 or even 15. So these are just agreed upon names so that we would have an easier way to refer to our different pipes. For each pipe, these inner and outer diameters are different as well as the nominal. For example, copper pipe A number 25 has this inner diameter, and it's not necessarily the same thing as steel carbon number 25's inner diameter. So now we know that different segments could have different sizes as well. Also, as you can see here, we have 25 and 32. So we don't have a pipe 30 here in between, as in steel carbon size 30 does not exist. It's either 25 or 32. Not only that, but also the unit for these sizes is millimeter. But the pipe sizes may be given by inch in the project, in which case we would see the initials NPS, which is actually nominal pipe size, which we will be talking about it later when we discuss the imperial inner diameters and outer diameters. For now, we're just going to be talking about the metric units that we have. So by pipe segment, we're actually referring to the different sizes. It has nothing to do with the materials because that's a whole different story. But here we're just talking about the pipe segment. Now here we have a limited number of type segments, but we might need another segment to use here, and we would need a new segment about which I will be talking about later on. Alright, now we're going to click OK, and now we know that we should definitely remember to specify our pipe segment. For now, I am going to select polyvinyl chloride. Also, let me tell you something. As you can see here, we have copper A, B, C, D. Or for example, here we have iron ductile with different classes. And the PVCs are separated by schedule, as well as the stainless steel, which also are separated by schedule. Let me open segments and sizes again. Let's select steel carbon and talk about this one. Alright, steel carbon schedule 40. Its ID is 15.799 and its OD is 21.336. Now check out schedule 80. Here we still have the same OD, but the inner diameter got a little bit smaller. It changed from 15 to 13 now. So this means that this pipe's wall thickness is a little bit bigger and it's stronger and more resistant. So for the high pressure parts, using pipes with bigger schedules is better. Now for different segments, different words are used to describe and differentiate these schedules. For example, for copper it's A, B, C, D, and for PVC it's schedule, as well as steel carbon. Or for example, here we have class. Or for example, for the copper right here, the letters A, B, C, D are used to differentiate and refer to them. But once we are using and talking about the imperial units, we will notice that we have KLM instead. So, different countries, different standards may also differ. Alright, now I'm going to close this mechanical settings window, and then I'm going to go here to the pipe segment and select polyvinyl schedule 40, or in other words, PVC schedule 40. For the ducts, we remember that we had no such thing as a duct segment or anything to specify different wall thicknesses. We only had to adjust the fitting types. Now, another thing is that we can also limit the size for drawing the different pipes. So we can also change that one. I'm going to go to segments and sizes again. And here we see that for PVC, we have different nominals from 15 to 300. As in, we have sizes from 15 to 300. But we can also choose to be able to see only the ones from 15 to 200, and we would want that 200 to be the maximum size that we can draw the pipes with. This is merely for saving ourselves from small errors, and so we would know that 200 is the biggest size that we can draw. This could also be useful for designing. Or we could say that we want the minimum size to be, for example, 20 or 25, and maximum size 200. So all these sizes, even though all of them are listed here in segments and sizes, we can limit them here as well. So that's all about the pipe segment. Now for the fittings section, we have to load proper families just like when we did for the ducts. So now I'm going to click on Load Family. And as you can see, I'm currently in English Imperial folder, but we were modeling the project with metric units. So I'm going to go back a folder, then go to English, US, then we go to Pipe, and then we go into the Fittings folder, and then PVC, then Schedule 40, and here the socket type is the same thing as the fitting types which we talked about before. So these pipes and fittings are connected through sockets. So we're going to open it and see some families listed here. We have cap, coupling, and cross and elbow. And we also have some other families in this DWV folder. This DWV stands for drain, waste, and vents. And all in all, they are just pipes which are not so resistant to high pressure. They're just for drains and watering. Let me move this window to the left a little so that we can select the right fitting easier. So we have so many different fittings to choose from. But the one that we are actually looking for, here we can tell that it's an elbow. So I'm gonna go over to the list, and let me tell you that elbows are named bend in here. So we have one bend and one bend long sweep. This long sweep has a bigger radius than this bend elbow here. So we can use either of them, but I'm gonna select bend. Here in this window it's called elbow, but here its family name is bend. You know, it's kind of like its birth certificate says elbow, but they call it bend at home. Now for its junction type, we prefer for it to be T, a trioed. We also have taps here, just like we had for the ducts, but I'm not going to select that one. We will use taps when it's necessary. For now, we want to have T's, so I'm going to hold the Control key. Then I'm going to look through all these families here, then find and select T reducing sanitary. So T reducing sanitary. We also have a T sanitary. While I'm holding the Control key, I'm going to select this one as well, and I will tell you their difference later. We also have cross, and remember I'm holding the Control key still. Now cross is referred to as T reducing double sanitary here. So this double is referring to cross. These are just names that these families have. It doesn't matter that it's not called cross here. What matters is its function, and you will become familiar with it. Now for transition, while I'm still holding the Control key, I'm going to go over to the list and select reducer. Now union, for this one I'm going to select coupling, and for flange we're not going to be using any, but for cap we're going to select the family that's called cap. So I just held the Control key, then looked to check which families were required. Then from the families in the PVC folder I found and selected them. And now I'm going to click open so that the families will be loaded into the project. So now the families have been loaded. Now I have to put them in the right places. As in, I'm going to go to the elbow section and open this drawer and select bend PVC. Now for the junction type, we said we wanted it to be T, but what type of a T? We're going to open the drawer again and select T reducing sanitary. Now for the cross, we're going to select T reducing double sanitary. Now for the transition, we're going to select reducer PVC and union coupling PVC. And flange is none, we said we didn't want it. Then for cap, I'm going to select cap PVC. Make sure you never forget to organize and specify your families here after you load them. If you forget to specify and organize them, it would be like you had gone shopping, but then left everything you bought out the door. You didn't bring them in, so it's kind of like you never even shopped anything. So make sure to put everything that you've bought in its place. Okay. And OK. So now we have adjusted our PVC fittings type. Now we have to specify the system type. If you remember, for the ducts we had supply, return, and exhaust. Now as for the pipes, let me open this drawer. We have different pipes as well. For example, domestic is for watering, and fire protection is for extinguishing fire. Hydronic is for heaters and air conditioners, sanitary for drains, we have vent for ventilation, and in case we had a pipe which was none of these types, we would have to select other. But now that we want to draw drain pipes, I'm going to select sanitary. Do you remember when we were reading the plan, here we saw this WP initials? If you recall, I said that this WP stands for waste pipe. So now I can take this sanitary and duplicate it and name that one WP. Just like when for the ducts we would duplicate supply and name it SAD instead, which was what we had in the plan. So now I'm going to head over to the project browser window, then go to the families, and then open pipe systems, then pipe system. Now the same things that we saw in the properties window, we see them over here as well. As in, if I click on the pipe command, all the system types that we see right here Also, in the project browser window and in the piping system, we can find them. Now we're going to right-click on Sanitary and duplicate it. Then right-click on the duplicated one and rename it. Type in WP, enter. Now we're going to press the enter key again. And then here in this window which pops up, we're going to go to the graphics and click edit. Then change the color of the drain pipes to red. Now OK, OK, and OK. So we adjusted the pipe type, and I'm going to set the system type on WP, which I just added. Now the pipe sizes, we go to the options bar and diameter, and for this one I'm going to select 100 because that's the size that we have in the plan. Now for the middle elevation, I would also have to pay attention to the slope. You know that our drain pipes also have a slope to them. The water drain is moved by the force of gravity. As in, we have an area drain here, the water pours into it, and then this pipe has a bit of a slope, and through that slope the water moves until it reaches the riser. So now, from the area drain up to the riser, the slope of the pipes is downwards. The highest elevation of our pipe would be here, and its lowest elevation would be over here around the riser. Let me create a section here along the pipe so you can see it better. There we go. Also, I'm going to make it a little bit smaller. In case you can't find the clip that you can use for this, we said that we could go to the Properties window, then to the Far Clip Offset section, and as you can see it says that the clip is 52 meters away from the section. But I'm going to change it to 1000 so that they would be 1 meter away. Now as you can see, they are 1 meter apart. Let me expand it a little. Right click and go to View. Now I'm going to expand it a little from below as well. There we go. So now our pipe is coming from here and goes downwards askew. So if we want to draw this, I'm going to go to the Annotate tab, then click on Detail Line. Then I'm going to draw a line around here, click, then drag it to here with a spontaneous slope and click. So now we can see that this pipe is askew coming towards here. Through the slope, the water moves and reaches the riser. So the highest elevation which we need should be somewhere around here. Then because this pipe has a slope, it becomes distant from this beam. But this is the part where it interrupts the beam. Let's measure it here, from below the beam down to the FFL. The number that we get is 359. So this should be the elevation of this part of the pipe so that it sticks to the beam. And then when it goes further, it also goes lower and becomes more distant from it. We know that our pipe doesn't start here, it starts a little far behind, as in it starts at a higher elevation. So now to begin, I'm going to start drawing with this elevation 359 for the axis of the pipe. Because this is the number that we got and it's kind of like a code, so we're going to use it to draw. Meaning that we want our starting point to be here, the farthest place from the riser, and we also want to draw it at the elevation 3590. So we're going to go to the Systems tab, then click on Pipe, then change our elevation to 3590. Now, how can we adjust the slope of the pipe? Up here in the ribbon section, we find a segment which says Sloped Piping. This is currently set on Slope Off. As in, if we draw a pipe right now, it would be drawn completely horizontally. Now, for Slope Up, if we select any starting point, it would draw a pipe for us with an upward slope. And Slope Down would draw a pipe for us with a downward slope. For example, now that we are about to draw a pipe from the area drain to the riser, its slope would be downwards. Or if we choose to do it the other way around, starting from the riser to the area drain, in that case we would have to select Slope Up. But now we're going to draw from the area drain to the riser, so Slope Down. And then over here, we're going to select 1%. If you pay attention here to this drawer, you will see that we have 3 different percentages for slopes. Not counting 0, we have 1, 2, and 4%. But what if I want a 0.5% slope or a 3% slope? How would I select and use that? Do you remember that mechanical settings window which we opened earlier? I'm going to use its shortcut MS. Now we go to the slopes section, then we click on new slope. For this new slope, we're going to type in 0.5. We click OK and OK. Now if we go over to the list again, we will see that 0.5% slope has been added as well. So you can add new slopes through the mechanical settings window. By far, we've adjusted all the other settings and now we can start to draw. So first I'm going to zoom in a little, then somewhere near this area drain, for example here, not inside the drain. I'll tell you about connecting pipes to drains later on. So click. Then I'm going to go along the plan and click again. The fittings that we have for drains are actually 45-degree fittings, meaning that I have to go further right along the plan and click where I need to. We're going to ignore this fitting and instead move upwards, then click right here, and then again at a 45-degree angle, we're going to click, and then we go to the riser and somewhere near it, we're going to click again and press escape. Now, why am I not able to see this pipe that I just placed? Why is it just a line? There you go. I have to set the detail level on fine. And also I'm going to set it on shaded so you can see it better. Now let's head over to the section. As you can see, this red line here is the pipe that we just placed. And this black one is the spontaneous pipe that we drew in the first place. So I'm going to delete it. And there's the pipe. We're still seeing a line, so I'll set it on fine and shaded. You can clearly see the slope of the pipe. Like if I just draw a horizontal line, annotate detail line, and I'm going to draw a line from here to here. It is pretty clear that this pipe has a slope compared to this horizontal line. Now for the starting point of this pipe, which was right over here, I gave the elevation 3590. Then when it went further, it just so happened to be at the proper elevation compared to the beam right here. As in, it's not a rule that we can just measure the distance from the FFL to the beam and have the right elevation, but we just got lucky. Because for example, this might have gone through the beam and we would have had to move it down, or if it was too low, we still could have used the arrow keys in the keyboard to move it upwards. So I just simply used this number I got here and started to draw considering this number. So from the area drain towards the riser, we drew the pipe with the slope 1% and with 45-degree fittings. Now I'm going to activate the pipe command again. Do you remember its shortcut? It was PI. Well done. Now with that same elevation 359 and slope down 1%, we're going to click and click again. And let me tell you that you shouldn't draw drain pipes and connect them with a straight 90-degree angle. Even if you have a 90-degree change of direction, you would still have to use two 45-degree angle fittings instead. This actually provides recurrent cloggings in the pipes, as in the water would move here and go further through a light angle. There are some exceptional cases where we would need to use a hard 90-degree angle, but as long as that's not the case, you would have to use two 45-degree angles instead. Now I'm going to delete this one. Now to help you understand the differences in slopes better, I'm going to draw 3 pipes over here. Pipe command PI. And for the starting point's elevation, I'm going to give it 3590. Now I'm going to draw a pipe with slope down, like so. Then escape. Now I'm going to draw another pipe with that same elevation, 359, with slope up. And now we're going to click and click again and escape. Now I'm going to draw another pipe with that same elevation but slope 0%. Click and click. Now escape. Now I'm going to take this section and move it over here. Now let's go to the section. Do you see these 3 pipes? This is our horizontal line. And the last pipe we drew didn't have a slope. Now this one's slope is upwards, and this one is downwards. But again, to help you understand it even better, we can increase the slopes. So I'm going to click on the percentage of the slope, then type in number 4 and press enter. Also here we're going to go to the pipe and on its percentage, enter 4, and there we go. So from whatever starting point we can have a slope down or a slope up, or we can also draw a pipe with no slope at all. But drain pipes require slopes, but for some other pipe types, for example the waterings, they may not require slopes that much. We will get to all of that later on. But for now I just wanted you to see the slopes up, down, and no slope at all. Now the pipes that have slopes, if we click on them, for example here we see the starting point is 359 and its ending point is 365. So we can easily see the elevations of the starting and ending point of each pipe. And in the middle of it we can see the slope percentage. The slope is upwards and 4%. Now this one, its slope is downwards and 4%. Started at 359 and with a 4% slope it got to 352. And this one has no slope. The elevation of its ending and starting points are the same. And the number that we see on the pipe is its length. So because it doesn't have a slope, it doesn't show us 0%. It only gives us the length. Now in case, like here, both ends of the pipe were open, we can click on it and click on the slope percentage and change the number. But in case like some of these pipes, for example this one, which both ends are closed for it, if I go to section and click on the pipe, we will be able to see the slope, but it's not selectable. No matter how hard I'm trying to click on this number, it seems like though I'm clicking somewhere empty. So it doesn't allow us to select it. So because both ends of the pipe are closed, and because changing the slope of this one would change everything else that's connected to it, the software chooses to lock it. Its slope can't change independently. Now, there's another thing. I'm going to activate the pipe command PI. Then with that same elevation 359, I'm going to select a slope up 1% and then draw a pipe like so. And if we want to draw it in reverse, as in slope down 1%, we're going to draw it like so, click and click. So they're both the same thing, it's just that we drew them differently on different sides. Let's go to section, and as you can see, both of them have the same slopes. We drew this one with slope up, and this one slope down. Now I'm going to click on this one, do you see its sign? As well as this one when we click on it. So they both have the same amount of slope, but here it says that this was the starting point. As you can see, this corner in this angle is starting from here and goes downwards, and this one means that the starting point was over here and went upward. Now if I click on this sign, the direction could also change, only that it shows us different starting points. So for drawing drain pipes, you have to consider 5 important points in mind. We refer to these 5 items as the golden left-hand rule. As in, I never draw a pipe unless I have checked all these 5 items in mind. Now, we say that this is the left-hand rule because I myself am right-handed, and because I use my right hand for the mouse, my left hand is free. So if you're left-handed, you can call it the right-hand rule. So I'm going to lift up my left hand, and I have it in a fist, and when I check an item, I'm going to lift up one of my fingers with it at a time. So we're going to go to the Systems tab and click on the Pipe command. Then I'm going to check the pipe type, and once I adjust it, I'm going to lift up one of my fingers. Then I'm going to check the System type, and when I adjust it, I'm going to lift another one of my fingers. Once the sizes are adjusted, the third finger is lifted. We're going to check the elevation and lift another finger, and the last finger with the slope. So you should never draw any pipe without considering all these 5 items. After you do that, then you can start to draw. This is very important to consider so that you make no mistakes during the process.